Ubiquity perceives position versus time in any off-grid environment without the assistance of internet, telephone, or any other complex systems. Actionable data analytics can be performed with Ubiquity devices and our elegant and efficient algorithms that infer complex information such as workflow and others. This picture shows the fundamental of how Ubiquity works. Basically, you place the Ubiquity boxes in any asset that you want to monitor, any asset whose position versus time you want to monitor. And those boxes communicate directly with the satellites, and that's for free. In an application, you will have Ubiquity boxes on the moving assets, but also you have to place just one Ubiquity box on a fixed place, because that one will help to refine the accuracy of all the Ubiquity boxes that you deploy in the field. The boxes, Ubiquity 1, the ones that move around, and Ubiquity 2, that is fixed in place, from the hardware perspective, they are identical. The only difference between them is how we are using them during the operations. We can use Ubiquity in different industries. We can use that in mining, the energy industry, biomedical, manufacturing, you name it. In this case, we are showing an open pit or mining area where one can see that Ubiquity boxes are being used to monitor the position versus time of the different places where they are drilling for mining exploration. And in that particular case, they would probably also want to use the Ubiquity capabilities to infer the workflow so they can optimize the workflow and maybe optimize how they deploy the regular crews, address complex robotics and automation, you name it. We have noticed that the typical modules in the field, the most clients want to use more efficiently are complex robotics and automation, complex assembling and handling in the field, perceived position versus time of these systems, address the logistics and the job orders, so everything is smoothly integrated, and of course, the return on investment is on the actionable data analytics. This diagram shows what we were highlighting in the mining industry, but this is for the oil and gas. It's analogous. Here you can see that we are putting the Ubiquity moving boxes on top of cranes. It could be on top of anything that you want to monitor position versus time. And you basically, in this case, you can assemble equipment that then is lifted with cranes and can be placed in oil wells. We can also use Ubiquity to monitor tanks or trucks that carry complex fluids. The ability to use Ubiquity to generate more revenue or increase the efficiency also needs to connect that with data analytics. Our team at Cambridge Research and Technology already offers a tool called Olympus 1000, which complements Ubiquity. Olympus 1000 runs on the cloud and enables remote access to the data, post-processing of the field data, and data analytics. In this diagram, you can see on the far right that we have put assets 1 to 4. They can be anything you are interested to monitor in the field. The colors are for the post-processing, so the upper management or the operators can see how the different assets have been moving around. In this particular case, we are showing in the vertical axis distance and the horizontal axis time, and the user can click in the area where they can choose what data file they want to look at. Olympus 1000 allows the user to have all the data in the cloud in a particular place from where the user can grab the files and they can see the plotting or run the data analytics. If the client were interested, Cambridge Research and Technology also has the capability to design the architecture of the whole system that will allow the client to address the different modules. As this drawing shows, some of the typical modules are modules related to assembling and handling, robotics system, how to deal with work orders and logistics, critical equipment, and of course, Ubiquity that allows to collect basic information. And all of that, we can design the architecture, we can design the architecture of the whole system and the architecture of each one of the modules, which is manifested basically in the flow chart. And then we can also develop for the clients the software that interacts with the hardware that the client already has or wants us to design and implement for them. And we also have the ability to produce the software that enables the graphic user interface. And all of that through data analytics. As you can see on the right side of this diagram, you have a central place from where you can run the actionable data analytics in a place far away from the field if you need. As this diagram shows, as we are designing the architecture, we may find that some of the modules relate to each other, and that is remarked by these green connectors in the outermost perimeter of this diagram, or the outermost circle. So you can see, for example, the critical equipment may need to be connected with the work orders and logistics, or with Ubiquity and so on. So we discovered that during the design. And then the arrows that run radially connecting the modules with the data analytics module communicate that everything goes to the cloud. And in the central system, we run the data analytics and the post-processing. To give a more concrete picture of one of the several types of Ubiquity boxes that we have, here we're showing, just for discussion purposes, one. The top area is more or less half the size of a piece of paper that you use in the printer, an A4 divided by 2. This particular one allows to sense position versus time of the assets, the level of battery that we have in the box, the temperature inside the box, whether the lid has been open or closed, and humidity outside. But we can sense many other characteristics of the field that the client wants us to implement. The size and the weight of the Ubiquity box depend on the reading frequency that one wants it to have. Additionally, its size will depend on the number of days the user wants Ubiquity to run on batteries without recharging for several days, 24/7. So this particular one allows for a frequency that one reading every 2 seconds can work for 15 days without recharging. But again, if the client has other requirements, we can adapt the Ubiquity to the requirements. Our company, Cambridge Research and Technology, can generate versions of the Ubiquity that adjust to special requirements from our client. This diagram remarks that Ubiquity can be recharged from a photovoltaic cell, from a box with batteries, or from maybe an outlet, electric outlet on the wall of the trailer from where one is running the operations. We can control, depending on the needs of the client, from one computer, several assets, or one computer for each one of the assets, okay? So what's next? As we said, Cambridge Research and Technology right now can provide the Ubiquity boxes in 3 formats, but we can adapt to the customer requirements. We can design boxes per specifications. We provide Ubiquity with its basic software, but we can also develop the data analytics software to get more value from the different Ubiquity boxes. In general, Cambridge Research and Technology is a consulting company that provides research and development consulting services and actionable innovations in a variety of engineering and scientific fields at any stage of the product development. Our company has a world-class R&D team that complements our clients' existing R&D team or does develop everything from zero. As you can see in this diagram, we can help our clients either on the feasibility and concept, TRL 1 and 2. We can help them in the crossing the valley of death, technology readiness level 2 to 6 or 7, and also the commercialization. So please, if you have any question, feel free to contact us. The link is already in the posting. We will be very glad to give you a detailed presentation, and we can converse about ways in which we could help you. Thank you very much.